All right, this is pretty fun. It's just talking about number lines and graphing solutions on number lines. Basically, they say draw a number line and graph the solution of this. Now, if you're good at freehanding lines, I would be okay with that with a number line. It's still always nice to use a ruler or a straight edge for your math drawings. So we're going to draw a number line and graph the solution of x is greater than 2. What that means is the answers to something are going to be everything greater than 2. It's kind of like if I said everyone older than 2 can go to Disneyland. That's not true, but let's say it was. How would we graph this on a number line? Everyone older than 2 can go to Disneyland. So you're going to go ahead and do the same thing. And I went out 4, down -3, and that's okay. So everybody greater than 2, does that mean the 2-year-olds can go? If you're older than 2, you can go to Disneyland. No, it means the 2-year-olds don't get to go. But do the 2.5-year-olds get to go? Well, yeah, I know that one's a tricky one, but actually, yes. So I guess up until your 2nd birthday. So maybe that was a bad example. What we do is, because the 2-year-olds don't get to go, they were not included, we put an empty circle there. If the 2-year-olds got to be invited go, that would be solid. We're going to do lots of this in the future, so hopefully this doesn't stress you out too much. We're going to revisit this a lot. So that's how we graph that. X is everything greater than 2. So numerically it means x can be 2.1, 2.3, 2.4. It can be 10, 11, 12. It could be all the way up to infinity, but not less, or not 2 or less. Okay, let's draw a number line. And this one has the or equal to. So now we're going to use the inclusive version of that. So here's my line. And this time it's less than or equal to 2. So now it means everybody 2 and under gets candy. So those of you who are 2 are thinking, if you're 2 and under, you get candy. Does that mean 2 gets to get candy? Yes. So we don't do an open circle anymore. We do a closed circle, because 2 actually is included. And it's less than, everything less than 2, everybody less than 2 gets candy. So that's the graph. We shade in the graph, or the number line, below 2 and including 2. So now let's look at this. It says write the inequality. Now in the book they give you some definitions and stuff, and I recommend that you look at that. I'm just doing the examples today. Write the inequality that describes this graph. All right, so we look at this and we say, all right, well, something's happening at -3 and below. So it's what I see here is the answer is less than 3, but does it include 3? No, it doesn't. So then we don't use that or equal to. So we don't have a line. We don't have a line here. If we did, then 3 would be shaded in. Oh, sorry, it's a -3. Now, if we had a line down here, it would mean that -3 was included, but it's not. It's an open circle. All right, so go ahead and do the practice and see how we do. Pause and then look at my graph. There's only 2 examples, so you can just keep this rolling, pause it, and come back and check. Okay. So put 0 here. Okay. That is less than 5 and including 5. So this one gives a closed circle. And shade in everything less than 5. All right, let's graph this or write the equation for this. All right, see, I see an open circle at 4. So I'm going to have an x and then something's happening at 4. And we're talking about everything greater than 4, but not including 4. So there is our answer. Now go back and look at the book too and read the lesson. So this makes a lot of sense. We're going to get way more in depth on this. This is just the beginning part of number line and graphing solutions of inequalities.